This is the second day of 0-9, the measures of center, spread, and position. So here we're going to bring back, if you learned a little while ago, the box and whisker plot, and something we call the 5-number summary. So let's get into it. Statisticians use measures of position to describe where specific values fall within a data set. Quartiles are 3 position measures that divide a data set arranged in ascending order into 4 groups, each containing approximately 25% of the data. The median marks the second quartile in the middle. So if you were to take a look here, the median, we call that Q2, which is the second quartile. Half of the data is to the left of it, approximately half of the data is to the right of it. Okay. The first and lower quartile, is Q1. It's essentially the median of the lower half of the data, while the third quartile is the median of the upper half. Okay. 3 quartiles along with the min and max are called the 5-number summary. We will talk about that here in the next slide. Although the graphing calculator will calculate the 5-number summary for us, we're going to have to find it by hand because you are required to do so on your standardized exams, the ACT and the SAT, etc. In this example number 1, it says the number of hours Liana has worked each week for the last 12 weeks were 21, 10, 18, etc., all the way down to 14. It says find the min, lower quartile, median, upper quartile, and the maximum of the data set by hand. So this is how we're going to do that. The first step is to place everything in order from smallest to biggest. The number of hours that Liana has worked, smallest to biggest, in the last 12 weeks. It looks like the smallest data item here is 10. And I like to cross off my data item so I don't forget. Next one is 12, 13, 14, 15, 16, 18, a couple of times 18, 19, 20 a couple of times, and then 21. So 20 a couple times and then 21. We have everything. So now to figure out what our minimum and our maximum. The 5-number summary, again, is the min and the max, the upper and lower quartiles, as well as the median. So the min and the max are the first things we should go for. The min is 10. And the max is 21. 2 of the 5 numbers already done for. Second thing we should do is locate our median, the number in the middle. So go ahead and start counting from the outside in, eliminating pairs as we go along. So let's see if we continue on, eliminating our pairs. It looks like we will come across 16 and 18. The median is exactly halfway in between 16 and 18. If you can't do that in your head, you could always add the 2 numbers and divide by 2. 16 plus 18 divided by 2 equals 17, which is your second quartile, or other known as the median. So we have 3 of the 5-number summary. Now what we need to do is to find the median of the lower half. We'll call that quartile number 1. Now when your quartile number 2, your median, falls in between 2 numbers, you will include both of the numbers on each side when you are trying to figure out the lower and upper quartiles. What I mean by this is we will begin eliminating pairs starting with 16. Starting with 16 and 10. So 10 and 16, 12 and 15, and then our first quartile falls in between 13 and 14, which is 13.5. This is quartile number 1. And then quartile number 2 is our median at 17. And then let's start with 18 and 21. Eliminate our pairs. We're trying to find the upper half, which is 19 and a half. That's Q3. And there you have it. What does this mean? It says, over the last 12 weeks, how do we interpret the 5-number summary? Over the last 12 weeks, Liana has worked a minimum of 10 hours and a maximum of 21 hours. She worked less than 13 and a half hours 25% of the time. 25% of the time was worked less than. Right here. This part is 25% of the data. She worked less than 17 hours, because 17 is our second quartile. She worked 50% of the data is over here. So she worked less than 17, 50% of the time, and then less than 19 and a half hours, 75% of the time. So that's kind of what we want you to do in terms of being able to describe the 5-number summary. So what we're going to do now is I want you guys to try this one on your own. The distances in feet Josie's last 10 discus throws were 90, 110, 103, and so on. So go ahead and pause the video, try it on your own, and once you get your 5-number summary, use this description to help you with your explanation. Okay, so I will go ahead and do it on underneath here. Go ahead and pause the video, try it on your own, and go ahead, and if you need to follow along with me, that's fine. 90, let's put it in ascending order. 92. The next one is 95. So I have 90, 92, 95, and then the next one would be 99, 101, 103, 105, 107, 109, and 110. Let's see now. Do we have all 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. We got it. So our min is the number at the very beginning. Our max is the number at the end. And our second quartile is the median. So let's go ahead and find our median. So the median is, let's see, we'll cancel off some pairs of numbers from the outside in. 109.92, 107.95, 105.99, and then now we're in between 101 and 103. That value is our second quartile, which is 102. So to find our first quartile of the lower half, we would take numbers 90 and 101, cross those off, and we'd come to 95 would be quartile number 1. And then the third quartile is the quartile, the median of the upper half, which is 107, is Q3. So to interpret the 5-number summary in this example, during her last 10 throws, Josie threw a minimum of 90 feet and a maximum of 110 feet. She threw less than 95 feet, which is our first quartile, 25% of the time, less than 102 feet, second quartile, 50% of the time, and then less than 107 feet, 75% of the time. So that's how we want you to interpret the 5-number summary for the homework assignment this evening and for our quiz coming up next week. The difference between Q3 and Q1 is something we call the interquartile range, and it contains 50% of the values. Before deciding on which measure best describes a set of data, check the data for outliers. We will ask you, depending on the problem, which measure of center is best to use, which describes the set the most accurate, in the most accurate way. And this idea of IQR and outliers will help us out. So an outlier is an extremely high or extremely low value when compared to the rest of the values in the set. In the past, when you guys were first learning how to do this, you kind of just looked for a number that didn't fit, a number that was just kind of high or kind of low. But now in this course, we want you to actually find that value algebraically using this interquartile range. So to check for outliers, we look for data values that are beyond the upper and lower quartiles by more than 1.5 times the IQR interquartile range. So in this example, We have the number of minutes each of the 22 students in a class spent working on the same algebra assignment are shown below. And you have a list of data items, 22 of them. And what we need to do is to identify the outliers in the data, because what we're about to ask of you is we're going to ask you to find the 5-number summary, or excuse me, apology, no, we're going to find the mean, median, mode, range, standard deviation, and variance of a data set with an outlier, and then we're going to take the outlier out and then describe the difference between the two when that happens. So what we need to do is first of all, we need to find the IQR, and we'll do that on the next slide here. So let's move over there. First thing we'll look at is the numbers written in ascending order. So in ascending order, starting with 10 and going all the way out to 65. That's our min, 10, and our max is 65. So what we're going to do is we're going to find the interquartile range. To do that, we first need to find the second quartile, which is our median. So let's go ahead and start with that. Now these are the answers. Okay, this is the answer, but I want you to use that at the very end of the response here. So just ignore that for now. You can write that later on your sheet here in a moment. So let's find the second quartile. We have 10 and 65. We will eliminate pairs as we move forward. 13, 30, 15, 30. Okay. So we'll see that my median lies in between 20 and 22, which gives me a second quartile of 21. Now to find the lower quartile, we will start with 20 and then 10, work our way down to find that our median of the lower half is 15. Quartile 1 is 15. The median of the upper half is 25. Quartile 3. So the IQR, the interquartile range, is Q3 minus Q1. In this example, 25 minus 15, which is 10. There we have it. IQR is 10. Now, in the previous slide, it said the outliers can be found by taking the interquartile range, in our example 10, and looking for values 1.5 times this amount beyond each quartile, 1 and 3. So what that looks like is now what we need to do is take 1.5 times this IQR. 1.5 times 10 is equal to 15. So what we need to do is take our quartile number 1 and subtract 15. Because quartile number 1, if you go back up to the number line, is here. We won't add 15 to that because then we're heading more towards the right-hand side. We're heading towards the median, the third quartile. We don't want to do that. We're trying to find outliers. Outliers are really small numbers or very big numbers. So we will subtract 15 from our first quartile, which in our example is 15. Subtracting 15. Anything beyond 0 in my set of data is an outlier. Well, the minimum number of the set in this data is 10. 10 is not an outlier. 10 is not an outlier. So let's figure out algebraically here if maybe 65 is our outlier. I'm willing to guess so. If we take Q3 and add 15 to it, our third quartile, if we add 1.5 times our IQR to the right-hand side, anything beyond that number is considered an outlier. So our quartile 3 is 25. Adding 15, we get 40. Anything beyond the number 40, not equivalent to 40. 40 is the ceiling. Anything beyond that, 40, 40 and a half, 41, etc., that is considered an outlier. So if we look here, 65, ladies and gentlemen, is our confirmed outlier. So what I want you to do now is I want you to find the mean, median, mode, range, and standard deviation with the outlier, and then I want you to do it again without the outlier, and I want you to conclude and compare your answers with the answers right here in the box. And once you've done that, what we're after here is we're trying to describe the effect on each measure. What happens when you take an outlier out of a data set? Well, take a look at all your numbers. Now, if you haven't done it yet, pause the video, do it. The mean goes down. The median goes down. The mode stayed the same. The range went down. And the standard deviation, look at that standard deviation. It cut it almost in half. So it says the removal of the outlier causes the mean, median, range, standard deviation to decrease. Notice that the mean is affected more by the outlier than the median. So what I would like for you to do here is to pause the video, try this on your own. I want you to do the exact same thing as the previous example. I want you to find the outliers, if there is one. Once you find an outlier, I want you to find the mean, median, mode, range, standard deviation with and without the outlier. Now, remember the standard deviation can be found using the graphing calculator. And if you don't remember how to do that, check out the QuickTime video that I posted from the day before on how to find it, or find me somewhere and I can tell you real quick how to do it, or Mrs. Rao or Mr. Long. We could tell you how to do it at this point if you haven't figured it out by now. So go ahead and try that, and I will go ahead and give you some answers here momentarily. Starting with the IQR, well, first of all, the data is not in order, so you have to put an order in ascending order from smallest to biggest. Now, in the interest of time and headaches of 26 data items, I will tell you right now that the interquartile range, I want you to do it, okay, but confirm with me that the IQR is equal to 7 minus 5. So we're gonna come over here, and once you figure out that the first quartile is 5 and that the third quartile is 7, what are we talking about here? The number of minutes each of the 26 students in a class spent to complete an obstacle course is shown below. So you have 26 students, they completed an obstacle course in minutes. The first quartile is 5, the third quartile is 7 minutes. The interquartile range, the middle 50% of the data, is equal to 2. Now remember, we need to figure out 1.5 beyond the IQR. So if I have 2, I'm going to take 1.5 that amount and come to our conclusion of 3. The IQR interquartile range times 1.5 is 3. So we got to figure out, hey, from our first quartile, if we go to the left 3 times, where are we at? From the third quartile, if we add it, where are we at? Q1 is equal to 5. 5 minus 3 is equal to 2. Now, take a look. This 2 would be the first set, the first data item in your set of data. It is not an outlier. Because it equals 2, it is the very lowest possible number. It's the lowest possible number. It has to be beyond 2, meaning 1.99999. 1.5, 1.7, just the number 1, 0, etc. 2 is okay. We are okay. It's not an outlier. Now, quartile 3 is 7. We will add 3 to it and get 10. If you see a data item bigger than 10, I don't know. Can you guys find it? I can't find it yet. Oh, wait. There it is. Anything beyond 10 is an outlier. So the outlier is 12 here, ladies and gentlemen. Find the mean, median, mode, range, standard deviation with the 12 in the set, and then take it out. Do the exact same thing, and I want you to come to these conclusions. The conclusions are as follows: with the outlier, with 12 in there, the mean is approximately 6.04. The median is 5.5. The mode is 5. The range is 10. And then the standard deviation, check out the video if you have to. the standard deviation is 1.89. Remember, you need to use a graphing calculator for that one. Now, without the outlier, the mean is 5.8. The median is 5. The mode stayed the same. The range decreased. And then the standard deviation decreased. Now you're going to find that the standard deviation will decrease when you take the outlier out. Think about it, ladies and gentlemen. If you take an outlier out of a set of data, it becomes slightly more compact, less variability is occurring, therefore a smaller standard deviation is taking place. If you take a look, compare, your mean decreased, your median decreased, the mode stayed the same, the range decreased, and the standard deviation also decreased. So at this point, you should be able to complete the assignment 0-9 day 2. And if you have questions, let us know.